In this video, we will be having a quick revision of the chapter Motion and Plane. So let us start with basic terminologies. Basic terminologies: null vector, magnitude of vector equal to 0. Unit vector represented as a cap, which is equal to vector A divided by magnitude of vector A equal to 1. Equal vectors: two vectors are said to be equal if their magnitude and directions are equal. Axial vectors use notation. Velocity is equal to r cross omega. Orthogonal vectors: if the angle between the two vectors is 90 degree. Parallel vectors if the angle between them is 0 degree. Anti-parallel vectors angle is 180 degree. Mathematical operation: let the vector A equal to a1 I cap plus b1 j cap plus c1 k cap and vector B equal to a2 I cap plus b2 j cap plus c2 k cap. Arithmetic operations: addition: a plus b equal to a1 plus a2 I cap plus b1 plus b2 j cap plus c1 plus c2 k cap. Subtraction: a minus b equal to a1 minus a2 I cap plus b1 minus b2 j cap plus c1 minus c2 k cap. Multiplication: dot product, scalar product: a dot b equal to ab cos theta, a dot b equal to a1 a2 plus b1 b2 plus c1 c2. I cap dot I cap equal to 1, I cap dot j cap equals to 0 and I cap dot k cap equal to 0, etc. Cross product or vector product: a cross b equal to ab sin theta and I cross j equal to 0, I cross j equal to 1 and I cross k cap equal to minus 1. Vector laws. Triangle law: if we can take two vectors as the adjacent side of a triangle, then the resultant vector will be the third side of the triangle taken in reverse order. So here y component of the vector b will be b sin theta and x component will be b cos theta. So resultant equal to a plus b cos theta I cap plus b sin theta j cap. Resultant vector equal to root of a square plus b square plus 2ab cos theta. This equation is used to find the magnitude only. And for the tan alpha, which is equal to b sin theta divided by a plus b cos theta. Then we have a similar law known as parallelogram law. Then the Lami's theorem. Here in this diagram, f1 by sin alpha equal to f2 by sin beta equal to f3 by sin gamma. Relative motion in 2D plane. Motion of one body with respect to other. Velocity of p with respect to q equal to velocity of p minus velocity of q. Umbrella problem. Vrm equal to velocity of rain with respect to man and Vrm equal to velocity of rain minus velocity of man. Tan theta is equal to velocity of man divided by velocity of rain. Riverboat problem, short distance. Vr equal to Vbr cos alpha and Vb equal to Vbr sin alpha. Vbr sin alpha equal to distance by time. This is equal to minimum distance is equal to Vbr sin alpha into t. Shortest time. Vbr is equal to root of Vb square plus Vr square and minimum time equal to distance by Vb, which is equal to root of x square plus d square by root of Vb square plus Vr square. Drift equal to Vr into minimum time and tan theta is equal to Vr by Vm, which is equal to x by d. Projectile motion, oblique projectile. X component ux equal to u cos theta and acceleration along x direction is equal to 0 and the y component ug equal to u sin theta and the acceleration along vertical direction is equal to minus g. Equation of trajectory, parabolic track. Y is equal to x tan theta minus half gx square divided by u square cos square theta, which is equal to x into 1 minus x by r tan theta. Time of flight. Horizontal projectile. Uy equal to 0 and ux equal to u. X equal to uxt, which is equal to ut and time is equal to x by u. Equation of trajectory. Y is equal to half ut square equal to half into g into x square by u square. Range r equal to uxt equal to u into root of 2h by g. Time of flight t is equal to root of 2h by g. Instantaneous velocity is equal to root of vx square plus vy square equal to root of u square plus g square t square equal to root of u square plus 2gy. Tan phi equal to vy divided by vx equal to gt by u. Projectile on inclined plane. X components equal to ux equal to u cos theta, ax equal to g sin theta. Y components ug equal to u sin theta and ay equal to g cos theta. Time of flight equal to 2u sin theta divided by g cos alpha. Height equal to u square sin square theta by 2g cos alpha. Range is equal to 2u square by g into sin theta cos alpha plus theta divided by cos square alpha. For maximum range, theta equal to pi by 4 plus alpha by 2. For maximum height, theta equal to 90 degree or alpha equal to 0 degree. Circular motion. Angular displacement theta. L is equal to r theta. Here L equal to arc length, r means radius and theta means angular displacement taken in radian. Angular velocity omega. Omega is equal to d theta by dt equal to 2 pi by t, which is equal to 2 pi f radian per second. Time period equal to 1 by frequency. And velocity is equal to r omega and v equal to linear velocity meter per second. Angular acceleration alpha. Alpha is equal to d omega by dt radian per second square. Acceleration, linear acceleration equal to r into alpha. Equation of motion on circular track. Wf equal to omega I plus alpha t and theta is equal to omega it plus half into n into alpha t square. Omega f square minus omega I square equal to 2 into alpha theta. Types of circular motion. Uniform circular motion and non-uniform circular motion. In the case of uniform circular motion, tangential acceleration equal to 0 meter per second square and radial acceleration is equal to v square by r and net acceleration is equal to root of tangential acceleration plus radial acceleration is equal to radial acceleration. In the case of non-uniform circular motion, the velocities are not same at different points. So the tangential acceleration is not equal to 0. So the radial acceleration is equal to instantaneous velocity square minus divided by r. So net acceleration is equal to root of tangential acceleration plus radial acceleration.